I'm Simon Danucci, and I've been a safety engineer and consultant for over 20 years now. So when I decided to start my own business, I was wondering what I was going to call it. And I looked around at various names, some of which were already taken, and I came up with the name The Safety Artisan for the business and the website safetyartisan.com if you want to take a look. And I came up with that name because I liked the word artisan and what it meant and the connotations. So first of all, I mean, artisan means a skilled person who does something by hand. And it can also refer to a thing that is, specially handmade, usually with high quality materials. So I like the sound of that. And I think it's appropriate, even in this modern age where I've worked on, huge projects, multi-billion-dollar projects that lasted for years and involved thousands of people. Because even on a big project, we're still relying on individuals being competent to do a job and to know how to do it, and to have that skill and that awareness and that understanding. So that artisanship, that appealed to me. I thought that's good. And another thing was that there's this connotation of somebody working alone at home, maybe a sort of a cottage industry type setup that used to exist before the Industrial Revolution. Or I should say, before the first Industrial Revolution. Now, whichever Industrial Revolution we're currently in at the moment, I don't know. But we've gone back to a world where, thanks to the internet, you can sit at home and do work. And in fact, thanks to, the recent global pandemic, more and more of us have been sat at home doing work, working remotely over the internet. And I, as an individual, can reach hundreds, thousands, or even millions of people over the internet with my teaching and with my knowledge and experience. So, the internet has really enabled a return to those kind of cottage industry ideals where individual people can do something of high quality and find a market for what they're doing, regardless of, big brand, big business, etc., etc. So we can, you and I can communicate one-to-one or one-to-many, and you can communicate with me, and we can learn together and share together what we want to do. Now, if that sounds good to you, if that sounds something that you're interested in, then please check out the videos and other learning products at safetyartisan.com. And you'll also find me, Simon Danucci, on udemy.com. So if you want to see what I do on a third-party platform, and then that's there too. Okay, well, thanks very much. And I look forward to seeing you again soon. Cheers. Hello, everyone, and welcome to. Hello, I made a sudden comeback there. That was finger trouble on my part. Welcome to this evening's webinar, which is a rerun of this morning's webinar on workplace hazard analysis. So welcome to the Safety Artisan. I'm Simon Danucci, and I'm going to be taking you on this little journey of a webinar this evening. As I say, I was on at 7:30 this morning, and it's now just gone 5:30 in South Australia. So welcome to you wherever you are and whatever time it is. So let's get on with the subject. I'm going to share the screen now. And whoops, there we go. So here we are. As it says, a free webinar from the Safety Artisan on workplace hazard analyses. And in this webinar, I'll be focusing on two tasks from Military Standard 882E, that's System Safety Engineering Standard. And tasks 206 and 207 are in the 200 series of analysis tasks. They're one of a family of 10. Okay, we'll hear about some more of those tasks in just a moment and how they complement 206 and 207. But before we get into that, I should say, justify, why am I here? Why should you listen to me? What of authority have I got to talk about this subject? So first of all, I've been in this business for around 25 years. And I've worked on a lot of different things in system safety. So lots of aircraft, fast jets, helicopters, big aircraft, ships, surface ships, that is, submarines, ATMS is air traffic management systems. I've done a little bit on trains and cars, not a lot, and lots of work on software and systems with lots of software in them. And I've been lucky enough to work on some really small projects, which is always nice, as well as some gigantic projects, including Eurofighter Typhoon. I did 13 years on and off on Eurofighter, enormous, $100 billion plus project. And that was just the acquisition cost, by the way. And also, not so happily, on the Australian Future Submarine Program, which spectacularly failed. But in a way, that's good for you, because I'm going to share with you my experience from things that went well and things that went not so well. But you can benefit from both. And as you might be able to hear from my accent, I'm from the UK originally, and I had a career in the UK. And then just over 10 years ago, I moved to Australia, and I've been doing system safety in Australia ever since. And I've worked on many US programs and also a variety of European programs. So I've worked a wide variety of military programs there. And on the teaching side, I worked on the team. I worked for the company that had the contract to present system safety training to UK Ministry of Defence staff. So I got to teach hundreds of people face to face in the classroom, which is great. It's nothing like it. And thousands online, so which is also wonderful. And so I not only taught courses but created courses for particular customers, which was great fun. And also I've been privileged to present on safety topics at several international conferences. So I've been around a bit, and hopefully, even though we're only together for a short time, you can benefit from some of my experience. So let's move on to our webinar topic for today. How do we do workplace hazard analysis? Okay, so that's what we're going to talk about. Now, it's worth pointing out that there's two kinds of workplace hazard analysis we could be talking about. First of all, there's the kind of analysis that you do when you're a worker or an end user, and you are doing a piece of work and you need to sort of look at what could the hazards be with this work that I'm just about to do, work that out, and then do the job. Okay. And typically, and we'll talk about this later, by the way, after the Q&A session. So typically, we will have either a job safety analysis, a JSA,
or maybe a safe work method statement. Now, there are lots of different techniques out there, but those are two of the most popular. Okay. What I'm going to talk about first of all, though, is acquisition analysis. So this is where we are buying or developing a system and we're thinking about how is it going to be operated? How is it going to be supported? What hazards to the health of people will this system or could this system present? And we're not going to talk about it today, but also fits neatly with those two analyses is the environmental hazard analysis, which is task 210 in MIL Standard 882E. But as I say, we're not talking about environmental today. That's a whole huge subject in itself. So those are our subjects for today. So let's talk first of all about operating and support hazard analysis. And I'll just call it OSHA from now on, not to be confused with the United States Occupational Safety and Health Agency or authority, or whatever it is, the regulator in the USA. So we're not talking about OSHA in the USA, or not that agency anyway. And as you can see here, it says the purpose of an operating and support hazard analysis is to identify and assess hazards introduced by operational and support activities and procedures, and to evaluate how adequate our risk mitigations are, whether they be procedures, facilities, processes, or equipment. Now, I've just remembered, before we go any further, can I just ask you for some feedback? Can everybody hear me okay? If you can hear me, somebody please send me a message. It's like it's coming through from the other side. Can you hear me? Just see if anybody sends it. All right, can anybody hear me? I did check my microphone earlier and it was working, but you never know. I've been caught out before. Okay, I'm not seeing a reply. I'm afraid not everybody on the social media channels can reply, so my apologies about that. The Restream connection isn't perfect. Okay, well, I'll trust that you can hear me, and we'll go back to sharing my screen. Okay, so that's the purpose of OSHA, or OSHA if you prefer. That's what we're going to do. Now, I do a whole lesson on this. I've just picked out a couple of slides as highlights from the lesson to talk about. And it's some tips about doing OSHA. So these days, we very often are buying legacy systems or something off the shelf. And so because we're not doing development, we may not have access to any design documentation whatsoever. Okay. So the traditional safety analyses, which are all around the design, we may not be able to do those. Okay, so you might be very heavily reliant on 206 because you've got what's in effect a black box. You say, okay, I've got to operate the black box, I've got to use it, and I've also got to sustain it, maintain it, train people on it, maybe buy spare parts or replenish it, dispose of it, whatever it might be. What are the risks associated for that? So really, our only sort of substantive hazard analysis might be task 206 and 207. So we could be, these could be very, very important. Now, having said that, we do still need to do tasks 201, 202, and 203, and they are, so 201, preliminary hazard identification, which produces a preliminary hazard list. 202, preliminary hazard analysis, where maybe we think about risk in big handfuls, big picture stuff. What's our strategy for addressing these risks? And then 203, which is system requirements hazard analysis, where we think about all the requirements that are pertinent to our system. So we might have legal requirements, we might have contractual requirements, we might have technical requirements or system requirements, we might have a specification for what the system is to do. So we need to consider all of those requirements. And in fact, I've done a different webinar about these three analyses and in broad brush what we need to do. So I refer you to that. That's still out there on YouTube, for example, and it's also on LinkedIn, but it's probably easiest to find it on YouTube if you look up the Safety Artisan Foundations of System Safety Assessment. So we still need to do those, as we'll learn why in a moment, but 206 and 207 could be the only in-depth analyses that we might do for a COTS or legacy system. Now, why do we need to set the context with earlier hazard analyses? Well, first of all, if we're not careful, 206 can become a bottomless pit in which we pour money. And the reason for this is if we have a complex system with lots of maintenance procedures and lots of operator training and lots of different things that the operator could do with the system, we could analyze everything to death and spend an awful lot of time and money and probably not get a lot of value for money out of doing that. So what we probably ought to do is prioritize our OSHA work based on those earlier hazard analyses. Okay, so this is why we must do those earlier hazard analyses. They're usually, 1, 2, and 3 are usually quick. They're pretty cheap. You can do them early with very little information, and then you can use the results of that to prioritize. What are the big risks? What are the problematic risks? Maybe they're not the biggest risks, but they're the most difficult to manage. Okay, so let's prioritize in those areas. But also, of course, do we need to do any hazard analysis at all for certain things? And you might think this is an odd thing for a safety engineer to say, but the truth is that we need to save our money and time for the things that really do need analysis. Whereas if we look at something and go, okay, there's the system that we've got is pretty standard. There's a normal expected way of managing the issues associated with this system that are, countrywide or industry-wide or internationally recognized. Let's just do that. Maybe we don't need to do any analysis at all. And a recent example of this, I was working on a program where people had decided they were going to do a fire safety analysis of a vehicle in accordance with an Australian standard. Now, there wasn't actually any requirement to do this, but the decision had been made. And I looked at this and I thought, well, this is a very expensive analysis, very time-consuming and complex analysis. Nobody, including myself in the company, had ever done this analysis before. So it was going to be a learning curve and it was going to take a long time. And I looked at it and I thought, well, actually, what are we going to learn from doing this analysis? Because when it comes to fire safety, okay, we typically use multiple levels of protection. So we try and prevent fire by eliminating sources of ignition or sources of fuel or eliminating oxidizers or heat sources that could cause a fire. We try and, if a fire starts, we try and detect it. And if we detect a fire by whatever means, then we try and put it out. So maybe we can have a built-in fire suppression system, or maybe we can have we can have fire extinguishers for staff personnel to use who are close by. And then maybe we just evacuate people if we can't control the fire and call the emergency services if that's appropriate or if we can do that. So we've got multiple layers of protection. So and probably those are all sensible things. So let's just do them. Let's not bother with the analysis, because it was, it's pretty likely that we're going to recommend those things anyway. So why spend the time and money doing the analysis when you just go, well, I know what the safety mitigations are going to be. Let's just do it. So there'll be instances where really the answers are pretty obvious. So we'll just Nike it, we'll just do it. So a couple of insights there on OSHA. Moving on to health hazard analysis. Now, as it says, the purpose of health hazard analysis is to identify human health hazards, not environmental, just human. Evaluate the proposed hazardous materials and processes that we think could or might be in the system, and then propose measures to eliminate the hazards if we can, or if not, to reduce the associated risks. Okay, sounds simple. In reality, health hazard analysis covers a lot of topics. This isn't all of them. I've just picked out 4 to talk about briefly. So the first one, hazardous materials or hazardous chemicals, hazardous substances, whatever we want to call them. This is traditionally a big part of safety engineering and safety management, because we often have hazardous materials. And certainly working in Australia with defence are ultra sensitive to the presence of hazardous materials, because they had a big scandal in the past with people working on an aircraft called the F-111, and lots, hundreds of people got exposed to toxic chemicals that were used as sealant in the F-111 fuel tanks. So that was a very high-profile scandal. Lots and lots of people sadly got hurt by these chemicals, and therefore, the Australian Defence Force are always going to be paranoid about these things, and we're going to spend a lot of time looking at these things and making sure that we're covered. So, secondly, ergonomics. And ergonomics is a big subject within ergonomics, and how you define ergonomics varies, I found, from country to country. So I'll try and make it clear. So first of all, there's anthropometrics. So, there's how tall is a human? Can they fit in the seats? Can they reach the controls or whatever it is they're doing? Can they drive the vehicle? How big are they? Because obviously humans vary quite a lot in size. And then around that, there's the wider subject of ergonomics, which isn't just around physical size of people, but all sorts of stuff, including, physical ergonomics. Are we asking people to try and work in a difficult space where they could, hurt themselves? Are we asking them to sit in a seat for hours and hours and be vibrated about? That could injure people. Are we exposing them, to mental stress or something, or we're trying to get them to do something that humans don't do very well? So there's all sorts of human factors there. Great big subject in its own right. And so that, there's a lot to consider there. Operating environment, I've mentioned vibration. Noise is another one, thermal. And of course, a big dread one, radiation. So anytime we've got radio frequency emissions, we've got some kind of transmitter, we're going to be producing non-ionizing radiation potentially. If we're producing some high voltage switch gear, we'll produce X-rays. Or we might have radioactive sources for various things. So even things like domestic fire smoke detectors. I've got one in my house. That's probably got a small radioactive source in it. Okay, probably completely harmless, but nevertheless, it's got to be managed and disposed of sensibly. So there's a lot of big subjects in health hazard analysis, and therefore it's one of the longest lessons that I do. So if you go to the website, you can access the lesson on health hazard analysis and the one on OSHA, they're $45 each. For example, the HHA one I think is over an hour long because there's so much material in it. Now, one of the reasons that there's so much material in it is that because MIL Standard 882E is an American standard, from the USA, it's tailored for American legal and military standards. So whereas, if you're working in the UK or Australia or, Singapore or, Brazil, wherever you might be, you're going to have to tailor this task for your country, for the legislation that's applicable in your country or where you're going to operate. So you might be buying something in one country, but it's actually going to operate in international waters or, in different countries, in which case you're going to have to make sure you're compliant with everywhere it's going to be. So that's quite a big task in itself. And the same for environmental as well. So, so it can be quite a complex job to look at things depending on where they're going to go. But tailoring the task will be crucial to achieving legal compliance wherever it is you're going. And as it says, substitute your jurisdiction of choice. Okay, it may not be Australian WHS, might be something else entirely. And I comment on those things in the lesson. So that's one of the commentary slides. The other one that I've decided to pick up on is, again, we need to set scope and priorities using tasks 1, 2, and 3. Okay, so very important that we do that. As I say, otherwise we can spend a lot of money achieving not much. And it may be for some specialist tasks, we need to bring in a specialist person. Because, okay, yes, we can do the work and we can do the research to train our own people up to do stuff, but is it really worth it? So for certain things, like looking at radiation and electromagnetic effects, maybe we need a specialist. Certainly at work, anything to do with electromagnetic effects and radiation, I consult a colleague who's a specialist in that area. I ask his advice, and pretty much I do as I'm told. Because even though I've been in the business 25 years, I don't know as much about this guy, about his chosen subject. So if you are lucky enough to be able to work with somebody who is a specialist in a particular area, do make use of them. Okay, can save you an awful lot of time and trouble. Okay. And one of the things that experience will tell you is that it's not worth doing a lot of work on stuff that has no credible impact on human health. So you might have some HazChem in your system. For example, if you've got American sourced electronics, you might have cadmium on your connectors in your electronics, on your PCBs, your printed circuit boards, sorry. Now, cadmium in certain forms is very, very toxic. But in reality, is there really an exposure path? So these boards are inside usually a sealed box, for which there's no need for the user to go into. And these days, even maintenance staff rarely open boxes up to change cards. We'd probably send it back to the manufacturer or a depot to get it fixed. So there's probably no credible exposure path during normal operations, okay, for lots of these things, whether it be asbestos, lead, solder, cadmium, chromate, funny chemicals that are buried inside systems. But that all changes when you have an accident, and in particular when you have a fire, because the high temperatures of a fire and the oxidation and so forth can turn relatively safe chemicals into actually quite toxic chemicals. So in the smoke from the fire or in residue left over afterwards, you might have some toxic chemicals that were never there before and you didn't consider because they didn't exist prior to the fire. So it's always worth thinking about survivability issues, and what about if you have an accident and you need to clean up or investigate afterwards. Probably people will need extra protection compared to the normal day-to-day job. So something worth thinking about with health hazard analysis. Okay, so trying to come up with a reasonable amount of effort to do stuff without going overboard, and focusing effort where it's required. So that's a little bit about those two tasks, which I hope will give you an overview. So what do you do if you want to take that further? Obviously, in a 45-minute webinar, or 1 hour, including Q&A, maybe we're not going to cover all of these subjects. So I've put up here a few free resources to get you started, and the links to these things are in the chat. Okay, and also I'll post them afterwards in LinkedIn and Facebook. And maybe put them in YouTube as well. I'd better. So by the way, I've already uploaded this morning's video to YouTube, so I will I'll post the links. In fact, I already have posted the links actually under that one, so you can get the links there as well. So worth saying, so free preliminary hazard identification and analysis guide. Follow the link and you can get that. It's a 50-page PDF that I've put together from reliable sources. There's a new free download on the website, System Safety Concepts and Principles, where I've taken a couple of lessons that I've used to sell, and I've moved on since I originally done those, so they're now free, but they'll give you some useful concepts and definitions and principles to help you get started in system safety. And if you wish, you can always go to the website or click on the link and subscribe for free emails. So please do that. So you'll get a bunch of it. You'll get emails from me regularly, once a week or once a fortnight, not too often, that give you an update on what's going on, and the articles, the blog posts that I've just released and whatever is going on. But you'll also get a little overview of how to make the most out of the website and my most popular videos on YouTube. So there's lots of content there, and you'll get some discount links should you decide to buy a lesson or a bunch of lessons, a whole course. So there's some big discounts available for subscribers. Okay, so that's the end of my little plug. Only 2 or 3 minutes, okay. And or not quite the end. So, and by all means, go to the website safetyartisan.com and see what there is there. There's lots of stuff there for you to look at, and as I say, a lot of it is free. So check it out and see whether you like what I do and the way I do it. Okay, so that's the slides for today. We certainly do have time. I'm going to talk about the job safety analysis and the safe work method statement in a moment. But before I do that, I just wanted to let you know that this is the 4th in a series of 5 webinars, and taken together, all the 5 webinars cover all 10 of the 9 out of 10 of the task of the 200 series tasks in MIL Standard 882E. So today we did 206 and 207. Next month we will do 205, 204 and 209. So those are subsystem hazard analysis, system hazard analysis, and system of systems hazard analysis. So all of those 3 things cover the hazard analyses that sit most explicitly within a systems engineering framework. Okay, so as we start on the V model in systems engineering, we might start off with looking at the entire system. When we have a subsystem specification, we then might look at each subsystem, and then maybe we've got to integrate our system with other systems that already exist. So we might do a system of systems analysis. Okay, so we would be looking at the front end, we would be looking at all the requirements that we need to generate, and then later on, have we verified those requirements? That's actually task 401 in the standard, comes later. And then ultimately, the whole system and system of systems approach has got to be validated. So how do we set ourselves up for success in a systems engineering framework? So that's what we'll be doing next month. Okay, so I'm now going to move to Q&A session, and I'm going to head back to join with you. So do please, if you have any questions on the subject that we've talked about, or indeed any questions at all about system safety, then please, if you can, send me a comment. And while you're thinking about that, if you can't think of anything, you are most welcome. You can send me a question on Twitter, on YouTube, on Facebook, on LinkedIn, or you can go to the website and submit a comment form on the contact page on the website, or you can comment on any post that is on the website. Okay, and then I will get an email saying that you've asked the question, and then I will respond to your questions as quickly as I can. Okay. Oh, by the way, you can also ask questions on Google My Business. If you look up the Safety Artisan, you will find stuff there. Okay, you can ask questions there and I will answer them. Okay, now I'm not seeing this. So what I will do while you're thinking about that, so first of all, you can get your free, oh, there we go. There's your link for your free PHIA guide. And, oops. And there's that download that I was talking about. And finally, if you click on the link, you can subscribe to for free emails. So please go ahead and do that, and then check your junk mail to fish it out with the junk mail, because that's probably where it will go to start with. Okay, well, I've not got any questions. So what I will do then is we will look very briefly at those two things I mentioned about the job safety analysis and the safe work method statements. And I'll get back to sharing my screen. So it's worth saying job safety analysis is a procedure for a specific job, where we look at the specific hazard or hazards associated with that job. And we're going to look at an example in just a moment. And then the safe work method statement is a more involved process, as we'll see. It's described as being a tool for identifying hazards. In reality, to be honest, it's just a more sophisticated and more formalized version of a job safety analysis, to be honest. It's not really that much more sophisticated. It's just that we, certainly in Australia, it is a legal requirement to do one for high risk work, as we will see. So it's regulated as opposed to unregulated. So we're going to go and look at those two sites. So first of all, let's get back here. I'm sharing my screen. So yeah, you should be able to see this. So I'm here on the Canadian Centre for OHS, which is a very good site, by the way. There's lots of good stuff on there. And on this page, it gives us a nice overview. It's got all of these topics. What is a job safety analysis? Okay, well, we've just talked about that. You know, we're gonna look at a specific task or job. What are the benefits? Well, obviously, we hopefully get to do the job without hurting anybody. So what do we do? 4 basic steps. Okay, select the job we're going to look at. We break the job down into a sequence of steps. We identify potential hazards, and we determine those. It says preventative measures to overcome these hazards. It might be preventative, or if the hazard, you know, maybe we're working on something that's very hot, so hot surface, so the hazard is there, it's unavoidable. Maybe we need to mitigate the risk of that hazard. So to say that we're going to overcome these hazards is maybe a little bit misleading, because some are just going to be there. Okay, we just got to protect people from them. Now the trick with JSA is really here. So as it says, how do I break the job down into basic steps? So there's 2 mistakes that we could make. First of all, we could just have big dollops of task. You know, we say, oh, I'm gonna overhaul an engine, okay, a vehicle engine. I think, okay, but that's not really breaking it down at all. So that's not very helpful. Or we could go too far the other way and break it down into lots and lots of tiny steps, and we'd make a huge amount of work for ourselves, and we'd probably just identify the same hazards over and over and over again. Whereas here, for example, we've got a slightly, let me just blow this up a bit because I'm not sure. That's better. We can see that a bit better. So here, I've broken it down into more reasonable chunks. So we've got to park the vehicle, make it safe. Oh, this is for changing a tire. It's a bit trivial. So we've got to get the spare tire and the toolkit. We've got to take the hubcap off and loosen the nuts or the lug bolts on the tire, and so on. Okay, so we've got a more meaningful breakdown, but we've not pulled it, you know, taken it down to the nth degree. So a reasonably chunky description of what we're going to do, and then identify hazards. Okay, and how do we identify hazards? Well, we use the same techniques. We use either, you know, experience, expert judgment, or we think about energy and toxicity. We think about the environment in which we're working, the you know, hazardous materials, perhaps. So yeah, so for this one, for changing a tire, maybe on the roadside, are we too close to passing traffic? You know, is the vehicle on uneven or soft ground? Could it roll? You know, could we hurt ourselves removing the spare tire and carrying stuff around, etc. So, okay, very useful, very widely used JSA. Pretty basic stuff. We go to a slightly more sophisticated view, and again, let's make this a bit bigger. So now I'm on the SafeWork, or I'm looking at a PDF from the SafeWork Australia website, which I highly recommend, by the way. Even if you're not in Australia, there's a lot of really good stuff in the SWA website, and which you may find useful. So I'm just gonna, there we go. That's better. So here's an example of the form, and we'll go back and forth on the form. But to start with, what is interesting is these 18 categories here. So what we have in this form is those things, and this example is for high risk construction work. So they've come up with 18 high risk activities that might be associated with construction work. Everything from working at height, maybe somebody might fall, disturbing asbestos, working near energized electrical installations. I think there was working near traffic or something. Anyway, confined spaces or diving work, okay, or working in an area with movement of powered mobile plant. There you go. So there's a whole bunch of things here that would prompt us to say, okay, we need to go into slightly more depth than we would with a normal JSA. We're still doing JSA type stuff here. We're still making a list of work tasks in a logical order. We're still identifying hazards and risks to workers or public with each one of those tasks steps. And then we're still coming up with control measures. So at root, it's still a JSA. We're still doing the same stuff, okay? Now, what is more involved about this is, because this is a legal requirement now for high-risk work, we actually have to have somebody draw up an SWMS, and for some things that those persons have to be pass a legal competency test to do so. So somebody has got to draw this up, and a person has got to be identified and sign for it. Somebody's got to review it. It's got to be dated, and we've got to describe who is who has control of the site, who has control of the work, what's the activity, what's the workplace location. So this is now a formal record, okay, and it's got to be retained for a certain amount of time, okay, and produced on demand. So if the regulator or a work health and safety representative demands to see this stuff, they've got to be allowed to see it. So this is now a controlled record, okay, and not only does the originator and reviewer sign it, but the workers who are going to do the work have to sign to say that they've read it and understood it and are going to comply. And here's the date on which they signed. So this might be a generic one that's been prepared earlier, but every time we go and do the job with different workers, all those who are taking part have got to sign. So it's like a JSA, but a bit more formalized. And as I say, because in Australia, this is now a legal, this is a record with legal requirements associated with that record. And so that is a very quick overview of a JSA and a safe work method statement, a SWMS. And do we have any more questions? Okay, I'm not seeing any more questions from anyone. So we've been on for almost 50 minutes now. So it just remains for me to say thank you very much for joining me this evening, or whatever time it is where you are. And I wish you every happiness and safety. So, and I will be back next month on I think it was the 14th or 15th of July. Okay. Well, thanks very much, everyone. And